Hey there, welcome back to the vlog. So today I want to cover something, again it's technology related, but this is probably going to be the most computer related vlog episode that I'm ever going to do. It really is practical, but it sort of borders on everything from quantum physics to philosophy to everything else, because it's one of those things that in order to truly understand what is possible and what's going on, you have to sort of really take a big step backwards and look at this absolutely massive picture. And it literally does break out of computing and back into the real world, and then from that into physics and everything else. So let me just start with, in some code that I've shown you already, we've had this concept of classes. If you're not a computer programmer, this idea will be foreign, for want of a better description. And to quickly explain it, you probably remember going to school, and in some biological science class there would have been a tree on a blackboard or a whiteboard if it's more recent years, and on there would be, here's animals, here's plants, and then the plants, they sort of go up through the tree as they evolve. And the same thing happens on the fauna side, where you've got your bacteria, and then you've got your sort of multi-celled organisms, then you've got your mammals, your fish, your reptiles and stuff, and then under mammals, for instance, you've got your cats, dogs, people, apes and things. And all of that kind of makes sense at that level. If, however, you're dealing with computers, what you end up doing is you might have, for instance, a description of one of those objects. So let's say you've got a description of a mammal. So a mammal has X number of legs, it's got a height, a width, a depth, it's got a weight, it's got a skin, whether it's feathers, fur, whatever. And there's an inherent property of the mammal that says, it has warm blood, it gives birth to live young. And pretty much you then don't have to describe what a mammal is when you go, right, okay, we're going to now create a new mammal, but this time it walks on two legs, and that will be your man. And we've got a mammal that walks on three legs, well, we can make one up. But we don't have to describe what the mammal is, so we just say that this thing extends this other previous class. Now, there's also this idea of instances. So there is the idea of a cup, but then there's a definitive cup that I could give you. Or there's an idea of a cat in my garden, or there are two specific cats in my garden. And these are instances of a class. So hopefully this much makes sense right now, but let's just go back to what actually defines a class. Because let's imagine we are going to have a container. So here is a container. It's just a plastic container. This container, as you can see, it has a height, it has a depth, it has a width going across, it has a volume inside that you can put something, it has a material that it's made out of, it's got a colour, which in this case is sort of a transparent colour, it has a weight, it has a thickness around the walls. Like, there are properties that define what this is. Now, there are also properties that are not immediately obvious. There was a date of creation, there will be a date of destruction, and these are also properties of this class. There was a date that the object was invented, as well as when it was manufactured. So we know that this is a container. Now, I can also take a different type of container, let's say this. Now, these share a lot of the same attributes because they are both containers. Like, they both have a height, a width, a depth, a weight, a material they're made out of. They have a capacity inside, or a volume. They have weights. Did I say weight already? They have, this one's made out of glass, whereas this one's plastic. So they're two different materials, but they're still a container. Now, I can take this container and take it one step further. Now I've got another container. Now this one is just like the previous two, but this one is now, it's got a handle on the side, so you know that changes things a little bit. You know, it's got a picture on it, which the other ones didn't, but it's still a container. But you know, this is now a mug, this is a glass, and the last one was a Tupperware. Those are 3 different subclasses of a container. So far, all of the containers we've had are all sort of drinking vessels or vessels that you put liquid in. So let me put down the cup. Let's now stay with this container, but now I'm going to bring this container into the picture. So this is a DVD container. You know, it also has a height, a width, a depth, a weight. It's got a picture, like this is a Wii video game for Batman. Like, you know, it has the same properties as this, but it doesn't look anything like it. You know, it's still a container though. You put something in it, it has a function for, you know, a purpose where you can store something in it, and you know, that's what its job is, but it's still a container. Hopefully with me so far. Now let's imagine I've got an idea in my head. So now you can't see it, but what is this idea? It's, you know, something that had a creation date, it just popped into my head. It will have a destruction date when it leaves my head. If I was to tell you the idea, I can make copies of it. I guess it has a location. It's in here somewhere. I don't know exactly where, but it's in here. I'm guessing it's going to take up a couple of electrons, so it means it has mass. You know, like, it's a thing. Now, what is the difference between that thing and, let's say, I don't know, the camera that I'm talking to? Like, you know, there are certain properties that are still shared, even though they're 2 totally different objects. One's a camera that I'm talking to, and the other one's an idea in my head. So, we know that they both have a location, they both have a date they came into existence, they both have a date they go out of existence, they both have a creator that invented them, they both have, like, you know, all these different metaphysical informational properties. And you know, this is where, going back to computers, something somewhere has to have a root. If you're going to represent something in software, there has to be a root object, a thing. And so this is where object-oriented programming comes in, because you spend a lot of time trying to work out what is a thing. Like, what is a thing? Well, in computers, it has a location. If it's going to exist in memory, then there's at least a location pointing to this thing. What that thing then looks like depends on, well, you know, you always have the root object, which is your object, which basically is a, okay, this is where this thing starts, and it has a class name so that, you know, we can say the root one is always, you know, if it's on iOS, it'll be like NSObject or object. If it's on, you know, the Win32, if it's a window object, it'll be a CWind, which normally comes from a C object. Like, you know, there's always an object at the root of everything. That's really what I'm trying to get at here. But then how things are broken down and inherited is, you know, you have objects which are derived from a prior object. So let's imagine we have an idea. So we can start off with an object. Well, that object then will add a creation date to it. So we already get, because it's an object, it has a location in memory. But we can now say, well, okay, this idea was thought up by this person. It has, you know, this creation date, and at some point when we've forgotten about it, there will be a date that it was forgotten. Except in a weird sort of paradigm here, that will never get filled out because we will have forgotten to fill it out. So, but that does exist. And, you know, the odd thing is, in memory, this exists, but this is where it gets a bit philosophical now, because let's imagine I've got something that in memory will have a date it was forgotten. The universe outside of my head, in theory, could fill in that date, because this object does exist. Because I thought of it, it does exist in the universe, and when I've forgotten about it, the universe will fill in the forgotten date, because that's what this object was supposed to do, and this object now exists because I thought of it. Philosophy just, philosophy and computers do not mix. But but they are sort of mixed in a weird way because the way we build computers is based on how we think in philosophy. Hopefully you're with me so far. So, we have this object and it's defined, but it's not an actual object until I make an instance of that object. So, I can define what a cat is and I can define what a new alien species looks like, but it doesn't exist until it's been actually created. So this is where, you've got instances being created of classes. But let's imagine, for instance, you've got a cat that's black and a cat that's white, and they mate. Well, we know that we get different colored patterns come out of them. And this is where it's like, you've got two classes combining to make a new class. That new class inherits from the previous classes, and they do call this inheritance. So, you inherit all of the information from the previous classes, plus you can add your own stuff in, like a new pattern, for instance, or a new weight of a cat, or a new skill that cat has that the parents didn't have. It gets really, really confusing when you think about this in any sort of level of depth. I mean, I know I could go on about this for hours, but I want to try and keep this very sort of light. But at the same time, I think it will blow you away when you realize just like, how weird things like this can get. And arguments like this, they can go on for days. And you can also get into very sort of, spacey discussions with people about this. Like, what is more important? Is it the information or is it the energy in the universe? And some people might argue, well, okay, information makes a book does not make information. Well, okay, yes, that's fine, but what describes the book? Well, information. If you've got something that has an openable section on one side and there's a sort of spine on the other side, well, this is information that tells me that this might be a book. I mean, like, you can end up going around in these weird circles. So I really just wanted to sort of bring home here, like, this idea in code where things extend from other things and things are derived from other things. Like, what is a thing? It's this very loosey-goosey philosophical idea at the root of it. And most programming languages that deal with objects, they have a rooted idea of what that thing is. But you have to wonder sometimes, is that a limitation that could be broken if we treat that root object as something totally different? So anyway, I'm going to leave this one here because, as I said, this can go on and on and on for days. Like, people have argued about this for decades, and it's one of those sort of arguments that I definitely normally sit on the side that information makes the universe, and therefore information makes the class. The class can then pass on the information to subclasses, and that's the way it should be. But there are people out there that argue otherwise, and yes, I'm not going to get into that. So anyway, if you like these videos, give it a thumbs up. If you don't like them, thumbs down. If you want to see more, please hit subscribe, and speak to you soon. Thanks, bye.